Good morning, 你好. Welcome to Blockchain and the Lindy Chen channel. My name is Lindy Chen. I'm very excited to be here and share my insight about blockchain with you. Yesterday, I shared with you the introduction of design blockchain solution and foundations of ownership. Today, I will share with you ownership identification. We will restrict access to our asset by various means to prevent unauthorized use of those assets. For example, we have locks on our car and homes, private file in our office, hashes. In section 1, we discussed how the use of hashes provides a fingerprint that identifies the asset, the block, and authorized party to the transaction. These same hashes restrict access to or the ability to transfer the asset ownership unless there is a specific set of instructions or keys contained in the block that authorize access or transfer of ownership under specified terms and conditions. It is not enough to state who owns the asset. The blockchain provides an irrefutable ledger of all the transaction history of transfers for the asset that lead to its current state of ownership. It is this audit trail of ownership that puts the ownership of the asset beyond doubt. Cryptography. Blockchain use cryptography to generate hashes, including digital keys, to protect data. If an incorrect key is used, such as someone trying to decrypt the key, then the result is a meaningless output of numbers, letters, functions, which will not reveal or provide access to the data within the block. Essentially, the hash tags will not align and the block is rendered useless and will be rejected from the blockchain. Typically, two keys are created for a purpose. A public key, used to identify users that map to the asset and the transaction. A private key, used to authorize the transaction. Clearly, using only one key will not allow a transaction to complete. In other words, no transfer of ownership can occur. This is known as asymmetric cryptography. Identify and compare transaction data. We have discussed the importance of hashes as identifiers of asset and parties to transaction, but the concept of hashing has additional function in the blockchain. It can be used to identify asset. It can be used to identify where data resides. It can be used to compare data. It can be used to determine when data has been altered. It can be used to create computational expensive data activities that deter hackers. So, what is hashing? It can be said that if you understand the concept of hash function, then you will understand blockchain. Hashing is the transformation of any kind of data into a number of fixed lengths. Simply stated, a hash function takes some input data and creates some output data. A hash function takes an input of any length and creates an output of fixed length. The following are examples of data hashes, where hello is the input data with the corresponding hash value. The hash value is unique for the input data of hello. There are numerous tools available to generate hash value. We will not be delved into how hash values are generated. For the purpose of this course, it's important to understand the concept of hashing and how it is applied in a blockchain. We are concerned with what is known as cryptographic hash function. These create digital fingerprints that accomplish some critical functions within the blockchain. They provide hash value for any kind of transaction quickly and simply. They quickly identify discrepancy in the block, by the discrepancy in the hash value and not the actual content of the data in the block. They cannot be reverse engineered. There is no way to trace input data, so there is no way to determine anything about the data content in the block. They are unique and resistant to duplication, so collision of hash values are almost impossible. Compare transaction data without comparing their content. The hash function is used to index the original value or input data, and then used later each time the data associated with the value of input data is to be retrieved. Put simply, if the hash value has been verified through consensus, then the input data remains the same unchanged. There is no requirement to compare the actual input data. From myself, the team at China Rex Sourcing, the team at Freezen Technology, and the team at Blockchain Collective, thank you for watching this video series. If you like what you see and hear and want to know more about it, please subscribe our channel and contact us. Good luck with your blockchain learning journey. Enjoy the program.